Hi, my name is Juliet Shelton, and this is my Physics 2 Lab 1 on the amount of excess charge on an ordinary object. So just to introduce this lab, the purpose of this lab is to determine how two charged objects interact with other neutral and charged objects and also with each other. So we are using pieces of tape to record these interactions and to estimate the amount of excess charge on a piece of U-tape. In the first part of the lab, we want to determine if the U-tape is positively or negatively charged. And then in the second part, we want to find the charge Q needed to make a suspended piece of U-tape float above another charged piece of tape at a given distance. We want to analyze charges in everyday objects and also demonstrate the effects of Newton's second law. And then the fundamental principles that we are using in this lab include the electric field and electric force, Coulomb's law, and Newton's second law. So some assumptions that I made for the lab was that the first one being each piece of tape can be treated as a point charge. And then also all of the charge is concentrated at the center of our point charge, which is the center of our piece of tape. And then lastly, that each U-tape we made has a similar amount of charge. So then just to describe how we actually applied the fundamental principles in this lab is that we assumed that each piece of the U-tape is its own point charge. And then we can then calculate the electric field and the electric force created by the two pieces of U-tape. Because the top piece of tape is motionless, the force of gravity equals the electric force, which then allows us to solve for the unknown charge value, Q. So then to begin talking about the data and measurements I had during this lab, first, my expectations. I expected that the two pieces of U-tape would repel from each other. That is because light charges repel, and we created the two pieces of tape in a very similar manner, so they should have the same charge. And then what I observed after carrying out the lab was that the two pieces of U-tape did repel each other, and they repelled each other very strongly. Then the U-tape attracted to neutral objects, such as the book, my hand, the desk. This was a weaker attraction, but they did attract, and this is due to the induced dipoles from the U-tape's electric field. Lastly, I observed that the U-tape attracted to negatively charged objects. This was the pen after I rubbed it in my hair. So because the pen was negatively charged after I rubbed it in my hair and the U-tape was attracted to it, we know that the U-tape is positively charged. And then we also know that the U-tape creates a negatively induced dipole when in contact with neutral objects. So to talk about the gravitational and electric forces that are demonstrated in this lab, the gravitational force and the electric field force from tape A are equal and opposite forces that act on the floating tape. Both of these forces are in the y direction, so there is a zero net force in the y direction. We also know that the momentum of tape B is not changing. So the electric force from the lower tape combined with the force of gravity on the upper tape resulted in an equilibrium of forces. For preliminary measurements, the length of my tape was 0.21 meters. The mass of my tape was 0.00021 kilograms. The distance between my tapes before they started floating was 0.012 meters. And then the first part of my calculation was to find the amount of charge on the U-tape. Using the electric force equation and rearranging the formula, I solved the charge Q as 5.738 times 10 to the negative 9th coulombs. If we divide the resultant charge by the charge of one electron, we get the number of deficit electrons on the tape to be 3.586 times 10 to the 10th electrons. Lastly, we wanted to determine the ratio of electrons to atoms on the surface of the tape. For me, this was 1.707 times 10 to the negative 8th to 1. This makes sense because the tape is positively charged, so we know that there are less electrons compared to the number of protons. So then using GlowScript, I did some calculations that I also completed in my PowerPoint. Running my program, you can see the two tapes as 2 point charges, and then the effect of the electric force and the gravitational force on the upper tape. The upper tape is represented by the ball. Then the green arrow is the gravitational force pointing downwards, and the red arrow is the electric force pointing upwards. The arrows are the same length and the same magnitude. So then lastly, to answer the questions posed from the lab, The first one is, what if electrons had positive charge and protons had negative charge? Well, my result would not change. The actual charge and name assigned to it are just convention. The tapes would still both have the same charge and would repel each other, no matter if they were both positive or both negative. As long as points have opposite charges, they will attract, and as long as they have negative charges, they will repel. And then why is it so important to handle the charged tapes as little as possible? This is very important because as soon as the tape comes in contact with other objects in the environment, such as my hand, they begin to transfer charges. If the tape came in contact with my hand for too long, it would begin to lose electrons in order to return to equilibrium and to become neutral. This would ruin the point of the experiment.